In this video, I'll talk about the Ampere's law. You might recall the Gauss law. What is the Gauss law? Tell you that the total flux passing through a closed surface is equal to charge enclosed divided by epsilon naught. Okay, so if you want to know more about this one, go back and watch my previous videos about Gauss law. So this is the surface integral. So that's the surface integral. And what does it tell you? That the total flux, this is the total flux here, or the E vector times ds vector is equal to the total charge that is enclosed by the surface divided by the epsilon naught. So if you are familiar with the Gauss law, the Ampere's law is exactly the same thing. The Gauss law is used to find out the electric field due to a charge or charge distribution. Ampere's law, in fact, is used to find out the magnetic field due to a current or due to a multiple current carrying wires or systems. So there is a quite similarity between those. Okay, Gauss law, electric field; Ampere's law, magnetic field. All right, magnetic field. So what is Ampere's law here? The Ampere's law tells you if I take the line integral of magnetic field around a closed curve, then it is equal to mu naught, which is a constant, times I enclosed. So you see there is a similarity here, quite similarity. The difference here is this is the line integral, this is the line integral, and this is the surface integral. All right, and instead of epsilon naught we have the mu naught here, but look at the ratio. This is multiplication and this is divided here, and I enclosed, and here we have a Q enclosed. So now let's look at an example here. So let us consider we have a loop here, closed loop. It has to be closed loop, just like a ring or any arbitrary structure, just a loop here. And through this loop we have four current carrying wires. I1 is upward, this is downward, or it can be at any angles too. Then what does the Ampere's law tell you? That the total, or if I just take this line integral of this one, then it has to be equal to mu naught times I enclosed. So in this case, all the current that is coming out of the loop is considered positive, and all the loop that is going into here is taken as negative. So I1 is coming out and I2 is taken as in. So I1 minus I2 plus I3 minus I4. So this is the enclosed current here, and if I multiply by mu naught, then this would be the integration of B vector dot dl vector. Okay, and this is, remember, this is a dot product here, and the dot product is defined by this way here. B vector dot dl is equal to B times dl times cosine theta, and theta is the angle between B and dl here, B vector and the elemental length here. Okay, so now in the next video I will show you the application of Ampere's law to find out the magnetic field due to a straight wire. So for now, just remember this equation here, and this is a very powerful law to calculate the magnetic field. The only drawback of the Ampere's law is it is used only in the case of symmetry, where the current flowing through a wire or due to a closed loop, it cannot be used to calculate the current due to a complicated structure. Okay, so this is it from this video. If you have any questions, write down your questions in the comment section below, and do not forget to like, share or subscribe the channel. Thank you.